So we've been dealing with exact derivatives, where we can do this, where we can work out the examples by inspection. But now, let's deal with these type of examples. So these type of examples, there's no exact derivative here. You can see that. Okay. So one is not an exact derivative of the other. So what we're going to do is we're going to use algebraic substitution. We're going to use U substitution. Okay. Let's have a look at the first one here. So I'm choosing specific examples from exercise 4.5 that deal with only algebraic substitution. So here we got the integral of x squared times x plus 3. Now in this case, there's no exact derivative here. If I let u equal to, normally, if I let u equal to x squared, the derivative of x squared will be 2x. And it's not going to cancel with anything here. Can you see that? Alright, so for these type of examples, let's have a look at the substitution we're going to use here. So if I let u equal to x plus 3 here. If I let u equal to x plus 3, and then du over dx, the derivative of x plus 3, the derivative of x is just 1, derivative of 3 is 0. So therefore du is equal to 1 times dx, which is dx. So du is equal to dx. Now, let me do the substitution. So I got x squared there, and I got the square root of x plus 3, but x plus 3 is u. Dx is du. We got a problem now. Can you see that? The problem here is we still have the variable x in this problem. Right, so how do we get the variable x, or x squared in this case, in terms of u? When we're using u substitution, after we use our substitution, there must be no x in this problem here. The variable x has to be converted to u. So what can we do here? We know that u is equal to x plus 3. But now there's x here. Can you see x? So what I can do is I can say, therefore, u minus 3 is equal to x. So now I got x in terms of u. And this is x squared. So if u minus 3 is equal to x, I want x squared, so I will square both sides. So now I got x squared is equal to u minus 3 all squared. So if I square it, it's going to be u squared minus 6u plus 3 squared. Minus 3 squared is 9, and that's equal to x squared. Now I have a substitution for x squared. So this is equal to the integral of x squared, which is u squared minus 6u plus 9. And this is multiplied by the square root of u. And now everything is with respect to u here. Can you see that? Now, what we need to do is simplify this. Obviously, it's multiplication here. We can simplify it. So this is equal to the integral of, I need to multiply u squared times square root u minus 6u times square root u, and then 9 times square root u. So I'm going u squared times u to the power half minus 6u to the power 1 times u to the power half plus 9 times u to the power half du. So I'm multiplying here. I need to simplify further. So we go back to our exponent laws. When you are multiplying and the bases are the same, write down the base once and add the exponents. So you're going to add it up. 2 plus half is 2.5, which is 5 over 2. 1 plus half, which is 1.5, 3 over 2, plus 9 u to the power half du. So we simplified. So now we can integrate each one. Okay. So now you know we're using the first type that we're dealing with when you got kx to the power n. So if you remember, if you got the integral of kx to the power n dx, this is going to be kx to the power n plus 1 over n plus 1 plus c. It's just a basic problem now. Basic integration to work out. So here I'm using x, obviously. In this case, it's with respect to u. So this is going to be u. We can add now 5 over 2 n plus 1. So 5 over 2 plus 1. 5 over 2 plus 2 over 2 will be 7 over 2. And that's 7 over 2 there. And I got minus 6 u. 3 over 2 plus 1. So 3 over 2 plus 2 over 2 is 5 over 2, all divided by 5 over 2. Here I got plus 9u, and then half plus 1. 1 over 2 plus 2 over 2 will be 3 over 2, all divided by 3 over 2 plus c. Now we're done. All we have to do is just substitute back for u. So this becomes 2 over 7, u to the power 7 over 2. Here, minus 6 divided by 5 over 2 is the same as minus 6 multiplied by 2 over 5. So that becomes minus 12 over 5. And that's u to the power 5 over 2. Here, 9 divided by 3 over 2 is the same as 9 times 2 divided by 3, which is equal to 6. U to the power 3 over 2. Plus c. Don't forget to substitute back for u. What was u? U was x plus 3, x plus 3 there, x plus 3. You can leave your answer like this, it's fine. But we're just going to simplify to check the final answer in our notes. So I'm just going to rewrite this back in exponential form. So remember, if you have x to the power a over b, we can rewrite this. This is a fraction which is a power. It can be written in third form. So you got the square root of x there. So remember from your n3 work, this is a and that's b there. Rewriting it back in third form. So now this is going to be 2 over 7, and then we got the root there of x plus 3 to the power 7. If it's a 2, you do not have to show the 2 because of the square root. So here this is minus 12 over 5, and then I got my 2 there, the square root of x plus 3 all raised to the power 5. Here it's plus 6 times the square root of x plus 3 all raised to the power 3 plus c. So these are the special case examples where there's no exact derivative here. There's no inspection here. You can see that. You have to use your u substitution and you make it work. Right, so copy this down. Let me give you a few minutes to try out the next one. Right, moving on to the next one, similar to this. Shouldn't take you too long to work it out. So here you can see again, there's no exact derivative here. Okay. So although it's multiplication, one is not an exact derivative of the other. So you can't do it by inspection. So we have to make it work by using algebraic substitution. We use the letter u. So if there's a square root, let u equals to what's inside the square root. Okay. So let u equal to, in this case, x minus 4. So you know now, when you come to this part here, you're replacing it with u. Now you need a replacement for dx, you need a replacement for x squared. Everything will be in terms of u. So let's see what happens. If u is equal to x minus 4, then we know that if I need to make x the subject, u plus 4 is equal to x. So u plus 4, if I square both sides, I got my x squared. Can you see that? So therefore x squared is u plus 4 all squared. So I got x minus 4 in terms of u. I got x squared in terms of u. Now all I need is dx in terms of u. So how do I get dx? That's a derivative. So du over dx, the derivative of x minus 4 is just 1 minus 0. Okay, simple, nothing difficult here. So du is equal to 1 times dx. That means the replacement for dx is straight du. Now it's all about simplifying. Okay. So what we need to do is exactly like what we did there. Squared. So that's going to be u squared. 2 times 4 times u, that will be plus 8u. 4 squared is 16 multiplied by u to the power half. Right, so now you know, it's just the process to follow. Remove the brackets because this is not in standard form. So I've got u squared times u to the power half plus 8u times u to the power half plus 16 times u to the power half du. Easy. You can see that? Now, when you are multiplying and the bases are the same, you write down the base once and you add the exponents. 2 plus half is 2.5, which is 5 over 2. Here, 1 plus half, 3 over 2, and that's 16 u to the power half du. In fact, it's a similar exponents there, you can see. So integrate with respect to u. All you're going to do is add 1 there on the top and the bottom. So that's going to be u. 5 over 2 plus 1 is 7 over 2. 7 over 2 there. And we got plus 8u. Now we are integrating. Remember, when we integrate, now we do not copy down the integration sign. When the integration sign is here, that means it's the question. When there's no integration sign, that means this is the answer now. Okay. So that's going to be 8u. 3 over 2 plus 2 over 2 is 5 over 2. 5 over 2 there. Integrate plus 16u. Half plus 1 will be 3 over 2. 3 over 2 plus c. You're done. Don't forget to substitute back for u. So I'm going to simplify at the same time 1. Remember, this is 1 divided by 7 over 2, which becomes 2 over 7. Here, 8 divided by 5 over 2, so 8 times 2 is 16, so that's going to be 16 over 5. We got the square root of u to the power 5 plus. Here, 16 divided by 3 over 2, that's 16 times 2, which is 32 over 3. And we got the square root of u cubed plus c, and you're done. What was your u? It was x minus 4. Easy, it just takes a bit long to do, but nothing difficult here. It's a simple thing. Just exponent laws and get all your variables x in terms of u. This is substitution. What is the next one there? Number 13. Let me give you a chance. Let me give you a chance to try this one out. Right, so the next one is a fraction. There's no square root there. But you've noticed that for this one, we let u equal to x minus 4. What's inside the root? And then we got x squared in terms of u. We did not we did not let u equal to x squared. Can you see that? No, the same logic we're going to use here. We won't let u equal to x squared because we're going to get x squared in terms of here. So what we do is we let u equal to x minus 3. So let me do it here. So if I let u equal to x minus 3, so I know this is going to be a u now. So therefore u plus 3 is equal to x, and I want also x squared in terms of u. So therefore x squared will be u plus 3 all squared. And don't forget about dx. You know that du over dx, the derivative of x minus 3 is just 1 minus 0, which is 1. So now du is equal to dx. We got a substitution for everything here. Right, the whole idea is the variable x must be out now. So this is now equal to, we are replacing x squared with u plus 3 all squared. You are replacing x minus 3 with u, and then you are replacing dx with du. Right, you can see now it's all about simplifying, like in N4. This is like an N4 problem now, where you have to square it, simplify it. Okay, so now you square this, that's going to be u squared plus 6u plus 9, all divided by u. So now it's not in standard form. You cannot integrate this individually, that individually, because this is a fraction, it's division. Okay, you will not find any of this in any under your standard forms on the formula sheet. So what do? If you do not see something that's in standard form, you need to simplify it further. Okay, so if I have something like 4 plus 2 all divided by 2, I can simplify this. I can write it as 4 over 2 plus 2 over 2. Okay, 4 over 2 is 2, 2 over 2 is 1, and 2 plus 1 is 3. We get the same result as if 4 plus 2 is what? 6. 6 divided by 2? 3. Same thing, different method to get to the same answer. But we cannot add here. Now here we could add, we could go 4 plus 2, which is 6, and 6 divided by 2, which is 3. But here we cannot add because these are not like terms. These are unlike terms, so we have to use the first technique. The first technique will be separate them into individual fractions. Again, nothing difficult to do. All you're doing is separating into fractions. That's going to be u squared over u plus 6u over u plus 9 over u du. Right, so now, if you didn't simplify, let me allow you to simplify further and integrate. Let's see what happens here. Let me give you 2 minutes, simplify that. Right, so you had time to simplify that. So u squared over u. Now here, when we are dividing and the bases are the same, it's exponent laws. You write down the base once and you subtract the exponents. There's a 1, 1, 1, so 2 minus 1 will give you 1 there. Plus, well, u and u will cancel, you get 6, and this is 9 over u. So you will write it as 9 multiplied by 1 over u. Because you do not take u to the top. If you take u to the top, it becomes 9u to the power minus 1. And you know that you cannot integrate when it's a power of negative 1. Why? Because minus 1 plus 1 is 0, and you have to divide by 0. It's undefined. So if it is u to the power minus 1, you take u to the bottom and write it as 1 over u. So this is a 9, so it becomes 9 times 1 over u. Same thing. Now we can integrate. So integrate u to the power 1, that's going to be 1 plus 1, which is 2 over 2. Integrate 6, that will be 6u. Don't write down x here, remember this is du. If it was dx, then it will be 6x. If it is dk, then it will be 6k. So it's u, it must be 6u. So now you got 9 multiplied by, when you integrate 1 over u, it's ln absolute value of u plus c. You're done. Don't forget to substitute back for u. Remember, this is a fraction, 1 over 2 there. So all I'm going to do is substitute back for u. What was u? U was x minus 3. Right, so that was number 13. How many minutes remaining here? Right, so we just did number 13. So number 13, we used, it's a fraction. We used u substitution. We simplified. Now this is, remember I said this is a fraction. Now this specifically is called an improper fraction. It's an improper fraction. So what is an improper fraction? When the numerator is larger than the denominator. The top is bigger than the bottom. That's basically it. So how do you determine when there is no numbers? How do you determine which is larger, which is smaller? You look at the highest power of x in the numerator, compare it to the highest power of x in the denominator, and this is a 2, this is a 1, so 2 is larger than 1, so therefore this is an improper fraction. Okay, which we're going to be dealing with the other example, under partial fractions, you'll be dealing with improper fractions. But it can be done here too. So what am I saying? What can be done? We can divide. Okay, this is an improper fraction, we can divide. So we use the method of long division. Okay, we are going to be dividing. So we can simplify this by using long division. So with long division, you got x squared divided by x minus 3. So let me write it down. X squared divided by x minus 3. So the denominator in long division is now given a new name. It's just called the divisor. Okay. So the denominator is now called the divisor. The numerator is called the dividend. Okay, that's the thing that you're going to be splitting up. Okay, the dividend, which is x squared. Now notice there's no other x here. So let's, standard form. When you have x squared is ax squared plus bx plus c. So that means plus 0x plus 0, because there is no plus bx, there's no plus c, so it takes on the number 0. Can you see that? Now, with long division, what is the method of long division? Well, you can always check. The method is DMSB. Okay. So it's D for divide, M for multiply. Well, let me just write that down. So you're going to divide, you're going to multiply, you're going to subtract. And every year I ask the students what B stands for. Most of the people get it wrong. It's not brackets. Okay. B means bring down the next term in line with what you just worked out. So basically it stands for bring down. Okay, it's bring down. Okay, so what are we going to be dividing? First of all, it must be in order from highest power to lowest power. If you had x squared here, it will be x squared first. Don't go and put minus 3 first. It must be all in order. So how are we going to divide? We're going to go, this is the dividend, all over the divisor. So term 1 divided by term 1 only. So that's going to be x squared divided by x, and the result, you write it directly above there, which is x. Right. The next step is to multiply. So the answer that you just worked out, the x, you're going to multiply it not only by x, but by every term here. So it's going to be x times x, which is x squared, x times minus 3, which is minus 3x. So I got x here times x minus 3, which was x squared minus 3x. Now, the next step is to subtract. So what are we subtracting now? Top minus bottom. So the top is x squared minus the bottom, which is x squared minus 3x. It's top minus bottom. It's just that I'm writing it horizontally there. So if you know horizontally, everybody can work it out. When it's vertical, sometimes you make a mistake. So it's going to be x squared minus x squared, and negative times negative is positive 3x. So the answer is just 3x. That's what happens. Right, that is working horizontally. But you don't have to do this. All you do is, when you are going top minus bottom, change the sign of the bottom term and add them up. Change the sign because you can see what happens here. This positive becomes a negative, and this negative becomes a positive when you subtracting. Can you see that? So that is the reason for changing the sign. So if this is a minus, make it a plus, and this is a plus, make it a minus. So we're going top minus bottom. 0x plus 3x is just positive 3x. Then we're going top minus bottom. 1x squared minus 1x squared is going to be 0. You must always get a 0 when you are subtracting your first term. That's long division. This is just one example. There's many other ones. Okay. Bring down. Now you might be wondering what is there to bring down. When you're bringing down, it's the next term. Like maybe if there was a 2 here or something, but let me just write it down. So we're bringing down 0, although it's unnecessary to bring down. So what happened now? We went through the 4-step process. Long division is 1, 2, 3, 4. So it's divide, multiply, subtract, bring down. Now you check what you have here. This is a positive 3x. Alright, it's a positive. Now you go through the process again, only if you have an improper fraction. So what do I mean now? This is your new dividend. Now forget about what happened here now. Now you focus on this part here. Now this is your dividend. The divisor is a divisor, that doesn't change. So now you need to go divide again, only if it's possible to do so. So I'm going 3x divided by x. Yes, we can divide here. Can you see that? So 3x divided by x, what do I get? Plus 3. Multiply. Now what do you multiply? Only the one that you worked out. Forget about this x. We are done with the x now. Can you see that? The one that you just worked out. So that's going to be 3 times x, which is 3x. 3 times minus 3, which is minus 9. Okay. So now subtract top minus bottom. So let me just do that on the side for you again. So my top is 3x minus everything in the bottom there, which is 3x minus 9. So it becomes 3x. A positive 3x becomes negative 3x. And negative 9 becomes plus 9. So what remains there? Just 9. Again, that is horizontal. This is vertical. That is just for you to understand what happens there. So you're going 0 minus 9, which becomes plus 9. 3x minus 3x, nothing here, that's a 0. Now, bring down, there's nothing to bring down. So we go back and now we check again. Is it possible to divide? So forget about everything else. This is your new dividend now. So let's check. If I go 9 divided by x. Now remember, this is 9x to the power 0. This is x to the power 1. So what is this now? This is called a proper fraction. It's not an improper fraction. Because the top is smaller than the bottom, 0 is smaller than 1. So if you have a proper fraction, that's the end. There's no more division. That means this is now the remainder. You can't go and divide anymore. So this is your remainder. This here is your divisor, this is your quotient now. Remember, this here is called quotient. Quotient is an answer to a division problem. So how do you write out the solution? This can be done in 1 minute. It's just that I'm explaining it to you step by step. In 1 minute you can do this. All you're doing is divide, multiply, subtract, bring down, and you're done. So now, what happens here? So therefore, x squared over x minus 3 is now equal to the quotient, which is x plus 3 plus the remainder all over the divisor. That is the result of the long division. Okay, if you want to make sure your answer is correct, you take your calculator in the exam I'm talking about. Yeah, when you're testing it out at home, any long division, all you do is take the right hand side and check if it's equal to the left hand side. In other words, take the right hand side like how you did in M3 and find the LCD here. LCD is going to be x, and then you work out everything, you should get x squared over x minus 3. Right, that is for practice. But in the exam, you only have a few seconds for checking. You know, you don't have all the time. So what you do is you take out your calculator and substitute a value for x. Let's take a value like, don't substitute 3 because 3 minus 3 will give you an error there, undefined. Let's take a value like maybe, give me a value, 2. Let's try 2. So put 2 on the left hand side in your calculator. What do you get? 2 squared divided by 2 minus 3. So 2 squared is 4. 2 minus 3 is minus 1. 4 divided by minus 1 is minus 4. So you know minus 4 is your left hand side. Do the same on the right hand side. Substitute your 2. What do we get now? 2 plus 3 plus 9 divided by 2 minus 3. So 2 minus 3 is minus 1. 9 divided by minus 1 is minus 9. 3 minus 2 is 1. So then 1 minus 9 we get. Did I do it correctly? Sorry, what did I say? 2 plus 3 plus 9 over 2 minus 3. So 2 plus 3 is 5. And then plus 9 over minus 1. So 2 minus 3 is minus 1 there. So it's going to be 5 minus 9, which is equal to minus 4. Right. So we got minus 4 on the right hand side, minus 4 on the left hand side. Obviously, this is done within a few seconds. Okay. You check that to make sure that your long division is correct. Now, remember, this took long to explain, but there's the solution here now for the long division. Okay. Now, what was the question? It was integrate. So I need to integrate x squared over x minus 3. That means I need to integrate x, I need to integrate 3, and I need to integrate 9 over x minus 3. All with respect to x there. Can you see that? So when I integrate x, what is the answer going to be? X squared over 2, integrate 3, 3x. Now, this is a fraction, 9 over x minus 3. So it's the same as 9 times 1 over x minus 3. You should be familiar with your exact derivative examples now. This is a fraction where the numerator is an exact derivative of the denominator. So this is the type f prime x all over f of x. And now it's up to you. Do you really want to use your substitution here? You can see the answer is going to be 9 ln absolute value of x minus 3. Let's see. So this is the type division. So that's going to be 9 ln x minus 3 plus c. And you're done. You're done. So this is the solution. Now, first thing, you'll be wondering, why doesn't it look the same? Okay, let's see. Let's see why it doesn't look the same. Right, so That was a long division, that's the solution. I'm going to erase this part here now. Okay. Now, why doesn't this look the same? Let's see. So what was the previous solution? It was, is it 1 over 2 times x minus 3 all squared. So my previous solution just read it out for me there. 1 over 2 times x minus 3 all squared. Next one?
6
minus 6
plus 6
plus 6 x minus 3 plus 9 ln absolute value of x minus 3 plus c, obviously. Right. So 8 plus c. So the only thing that matches here at the moment is this here. Can you see that? From the previous solution. Now let's see what's happening with the other terms. If I have to go and simplify this. So now, let me simplify. So this is going to be 1 over 2. X minus 3 all squared is the same as x squared minus 6x plus 9. 6 times x, that's 6x. 6 times minus 3 is minus 18 plus 9 ln absolute value x minus 3. Right, now I'm going to remove the brackets. So half times x squared is half x squared. Half of negative 6 is negative 3. And half times 9 is 9 over 2. Plus 6x minus 18 plus 9 ln x minus 3 plus c. Let's add up our like terms now. So I've got 1 over 2 x squared there. 6x minus 3x is going to be a positive 3x. Now, then I got my plus 9 ln x minus 3, and now my constants. Yes, I got minus 9 over 2. 9 over 2 minus 18. Yeah, so that's what? 4,5 minus 18. What do we get then? Minus? Minus 27 over 2 plus c. So now look at this. Term 1, half x squared. There's your half x squared. Can you see that? Term 2, 3x. There's your 3x here also. Term 3, 9 ln of x minus absolute value x minus 3. That's fine. And any, you see the c here represents constants. It could be 5 constants. It could be 6 constants. So this is a constant. So this here is, you don't even have to worry about this. This all can be represented by the letter C. Okay, how can you trust what I'm saying? You do this here. You take an example like this here. You put a value, let's say put a value like, let's see what value can we put here. If you remember, when you come to area, we're going to be dealing with this here. So let's say you put a value like maybe, let's say 5 and 4. Okay, this obviously you need the advanced calculator to do it one time, which is that one. To use the advanced calculator, you'll get an answer. You do the same thing here. Obviously, you all can do it with this calculator. You're going to put 5 here, 4 here. So let me go. 5, 4. I'm just using an example. You do the same here. 5, 4. So how do you do this? You're going to put 5 into this answer here. You're going to put a minus sign. Then you're going to subtract. You're going to put 4. You will get an answer. You do the same thing there. You must get the same final answer, no matter what. If this final answer is 10, that must be 10. That's another way of checking your two different methods. Alright, but we will be dealing with more long division when we come to partial fractions.